Right, today we are going to discuss about a very important protocol called BGP, Border Gateway Protocol. Now this is an extraordinary, this is a very different routing protocol. This is totally different from other routing protocols in many sense. It is different. Now the name as it goes, Border Gateway Protocol, this is one of the this is the protocol that works in between the borders like this. So this is one autonomous system and this is another autonomous system. Now between these two we have BGP. So BGP is a protocol that is recommended to use when we have multiple autonomous systems. So this protocol is categorized under a category called EGP, Exterior Gateway Protocol. Why? It is exterior, it is outside, it talks outside the autonomous system. This is a protocol that is recommended to run between autonomous systems, not within autonomous system. So this protocol is meant to run between autonomous system, not within autonomous system. All those protocols that is running within are called as IGP protocols, Interior Gateway Protocol. Example for Interior Gateway Protocol or RIP, IGRP or EIGRP, OSPF, ISIS. Whereas BGP is a EGP protocol, Exterior Gateway Protocol. B stands for Border Gateway Protocol. What type of protocol it is? It's an exterior protocol. It is meant to run outside the autonomous system, not within the autonomous system. So it is EGP protocol. Now this is the protocol that works on top of TCP. The other protocols are UDP protocols. They use multicast to discover neighbor because there is no TCP in them. In other protocols there is no TCP, so they use multicast address and discover the neighbor. Whereas in BGP we do not use any multicast address to discover neighbor. The reason is it's a TCP protocol. BGP is a TCP protocol. BGP works on TCP 179. That's the port number of BGP, TCP 179. Very important number that you should remember. BGP uses TCP port number 179. Now, because it's a TCP protocol, neighbors we need to statically configure. We cannot see dynamic discovery of neighbor in TCP because TCP needs acknowledgement, because TCP is connection oriented. It needs the neighbors to be statically configured. In all other routing protocols, we have seen the neighbors will automatically come when OSPF or EIGRP runs on an interface. But here neighbor will not come and update will not be sharing unless we say the neighbor statically. Why? It's a TCP protocol. It uses TCP port number 179. So this is the port number through which they establish the neighbor. After establishing the neighbor, they send and receive BGP update. They exchange the BGP update. Now BGP that is working between autonomous system, we call it as eBGP, external BGP. The BGP that you enable between autonomous system. So this is one autonomous system. This is another autonomous system. When I run BGP here, we call that BGP as external eBGP, external border gateway protocol, eBGP. So BGP sessions between two BGP peers is said to be external eBGP session if the peer is in different autonomous system. So if I am forming neighbor with a BGP router which is not in the same autonomous system, then it is eBGP. If a neighbor is established, if a session between BGP peer is in the same autonomous system, then we call it as IBGP, internal border gateway protocol. Meaning, if I have two routers inside this autonomous system forming neighbor with BGP, then it is IBGP. If neighbors are formed between two routers that belong to different autonomous system, this belong to this autonomous system, this belong to this autonomous system, then we call it as eBGP, IBGP, eBGP. So BGP session between two peers is said to be internal IBGP if the BGP peers are of same autonomous system. By default, the peer relationship is established using IP address, meaning if I have two routers and if I want to form neighbor between these two routers, let's say this is A and this is B, and I want to form neighbor between these two routers, and the IP address of this interface is 10.0.0.1, the IP address of this is 10.0.0.2. Now these two routers can form neighbor by using the IP address of the interface. As I told you, we need to manually configure the neighbor. When I go to router A and say neighbor 10.0.0.2, and router B, when I go here and say neighbor 10.0.0.1, they form neighbor. Now neighbors are formed by using the directly connected interface IP address. There is also another way of forming neighbor by using the loopback interface address. Let's say behind router A I have 1.1.1.1. Behind router B I have got 2.2.2.2. Now I can also form neighbor using loopback interface address which is not directly connected. For that, the command that we use is update source command. Now if you are forming neighbor with an address which is not directly connected, then we need to use an update source command. We need to use a command called update source. I'll show you as we get into the configuration. Now, why someone will use loopback interface address as a neighbor? Let's assume there are two routes between router A and router B. There are two links. If I form neighbor with one of the link, if that link goes down, I lose my neighbor. But if I form neighbor with the loopback address, even if this link goes down, I have another link through which I can form neighbor. So neighbor will remain as long as any one of these interfaces is up. So whenever we have redundant links, we use loopback interface. We can use any interface other than directly connected. You can use, then you need not to use update source command. Other than this directly connected, you can use any interface, but recommended is loopback interface. Why? Loopback interface is a logical interface that will go down only if the router goes down. Physical interface may go down for many reasons, but loopback interface will not go down because it's a logical one. As long as the router is up, the loopback interface will be up. So it is recommended to have neighbor with loopback interface whenever you have redundant paths, multiple links connected to the neighbor. As we already discussed, when we have multiple paths, we use loopback interface to form neighbor. Whenever we use loopback interface, what we do is we use update source command. Now next is BGP can be having multiple paths like this and do load balancing, but this is too far away from our course. If you want to do load balancing in BGP, MPLS VPN is important, which is not our area of study in CCNP. So BGP is not meant for load balancing. BGP alone cannot do load balancing. BGP depends on MPLS VPN to use multipath load sharing. If no MPLS VPN, BGP will not do load balancing. BGP is not meant for load balancing. It will use one of the path. It won't use all multiple paths. So BGP multipath load sharing for eBGP and iBGP features allow us to configure multiple load balancing with both eBGP as well as iBGP. We can do load balancing both in eBGP as well as iBGP, but what we need is multi-protocol label switching, MPLS label switching, and MPLS label switching VPN for that. This is what an example topology for MPLS. Now, between this PE router, provider edge router, and between this provider edge router, we form tunnel. We form VPN. Now, when we have something like that, you see there are multiple paths. This PE1, let me call it as 1. This is 2. This is 3, and this is 4. For PE1 to reach PE4, there are multiple paths. It can go like this. It can also go like this. It can go like this. It can go like this. There are multiple paths. So multiple paths can be used for load balancing when we have what? MPLS VPN. This feature provides improved load balancing deployment and service offering capabilities. Because we have multiple paths, the service offering will be more good. So this is used in multi-homing. What is multi-homing? Connecting to more than one autonomous system. Multiple provider edge router. Autonomous system and provider edge router with multiple neighbors. So it works in both eBGP as well as iBGP. When we have multi-home, what is multi-homing? As I already said, multi-homing is connecting to more than one. If you see this PE router, this is multi-home. This is connected to here as well as here, multi-homed. When we have multi-homing, we have multiple customers. When we have multiple customers, we have multiple VPN. And when we have multiple VPNs, to reach a particular destination, load balancing can be done both in IBGP as well as EBGP scenario. But BGP alone cannot do load balancing.